first thing, just some terms that you are going to hear when we are talking through this. Some of the different payment periods. If I say annually, what does that mean? Yearly. So one time per year. Okay, what do we mean when we say semi-annually? Every 6 months. So 2 times per year. What is quarterly? Yep, every 3 months. So 4 times per year. Monthly would be and daily. Let's exclude leap years. So that would be okay. So we could have different payment periods, but those are the ones we see the most often. So the terms that we will have as we go through here. Interest formulas, we have done simple interest in some of our word problems before. Interest equals principal times rate times time. However, that's not typically the kind of interest you're going to be dealing with. If you take out a loan at the bank, you don't just pay them interest one time and call it good. They do what's called compounding interest. So they stop maybe every month, calculate how much interest you owe, add that to your loan amount. And so your interest is constantly growing, or just like your savings accounts. Okay, they don't just pay you interest one time a year. You get paid interest on a regular basis. So the compound interest formula, I will give you the formula, but I'm not going to tell you what the variables stand for, so you need to be familiar enough with it that you can do that part. So A is the ending amount. Sometimes that's called the future value. It's what it will be worth. Equals P, which is your principal or your present value, the amount right now. 1 plus R is your interest rate. That is always as a decimal. N is the number of times we compound each year. And T is the number of years that we are finding. Then the second one is continuous. So we stopped at daily, but we could compound interest every hour if we wanted, or every minute, or every second. And so that leads into continuous compounding, when it's constantly growing. So that's the A equals P E to the RT. So AP, RT, those are the same as in the previous formula. E is actually a button on your calculator. It's kind of like pi. It has a set value. So if you look on the natural log button, your LN, couple buttons above the on, you do second, and the natural log, it has the E. And that's an exponential. It has the meaning of it comes from calculus, so there's a reason that it is what it is. But for now, you just need to know how to use it. Okay, so if I say continuous, you use this formula, otherwise we're using the regular one. So now we're just going to practice.
Will we be doing everything with the first 2 decimals?
Yes, so if we are finding the interest, that's a dollar amount, so we'll go to 2 decimal places. So A, find the future value of $100 invested at 4%, compounded quarterly after a period of 13 quarters. So, future value is what variable? A. So we are looking for A. What is our P, our present value? 100. What is my interest rate?
0.04.
N, how many times are we compounding each year? 4. Quarterly means 4 times a year. And then T. T is time, but it has to be in years. How would I change 13 quarters into years? Divide it by 4. There are 4 quarters in a year. So if you do 13 over 4, or what does that turn out to be? 3.25. So either one is fine. But the Rate has to be in decimal form, your time has to be in years. So then we're just going to do our calculation. A equals P times 1 plus R over N T. So 100 times 1 plus 0.04 divided by 4 to the 4 times 3.25 power. I strongly recommend just typing everything in at once on your calculator. When people try to do this in steps, it seems to create a lot of problems. So we have 100, let's see, 1 plus 0.04 divided by 4 to the 4 times 3.25 power.
Oh, I see.
Find it?
Yeah, forgot.
So if we round to 2 decimal places, what do we get?
113.81.
Did anyone not get that? So that is my future value. That's the first question. Part B, I want to know the amount of interest you earned. How would I find how much interest you earned?
You subtract it from the
Right. This is what I ended with. Minus, I started with 100. So I was paid $13.81 in interest. Is that okay? Let's look at this. Leah must pay a lump sum of $15,000. Part A. What amount deposited today at 4.8% compounded annually will give $15,000 in 42 months? So, what is, do I know my A? Right, my future value, that's what we want in the end. So that's my 15,000. Do I know my P? No, that's what I'm trying to find, how much we have right now. What is my interest rate? Point. Mm-hmm. Okay, N, how many times are we compounding each year? Annually means 1. Semi-annually is 2. Time. What would we do to get our time? We're 2 divided by 12 and we get 3.5. So my formula. A equals P 1 plus R over N to the NT power. Plug in what we have. A is 15,000. I don't know P. R is 0.048. N is 1. 1 times 3.5. You can clean up a little bit. 0.048 divided by 1 is 0.048 plus 1, so 1.048 to the 3.5 power. So then how do we get P by itself? P times this, so we would so we get $12,729.95. Let's look at part B. So let's say she doesn't have that much money. She only has 10,000. What interest rate would she have to get to increase it to 15,000 in 4 years? Bigger than 3.5, higher interest rate, more interest you're getting. So we still need 15,000. P, how much do we have? R, this time we are trying to find this interest rate. N, I still said annual, so my number of times is still 1. What is my time? 4 years. Okay. So my A, 15,000 equals P, 10,000. 1 plus R over 1 to the 1 times 4 power. What would I do with my 10,000? It's multiplied, so we would divide. So 15,000 divided by 10,000 would be 1.5. 1 plus all of the ones just R to the 4th. Then what would we do? Typically we would do a plus or minus. We actually don't need the minus here because an interest rate is always positive. So then to get the R by itself, you would have to subtract 1. So we get the 4th root of 1.5 with a minus 1 on the end. All right. This is an interest rate, so we need to probably keep more than just a couple decimal places. So, yeah. So about 10.67%. So we would have to have a pretty high interest rate in order to make that happen. Is this okay so far? In general, the more often you compound, what's going to happen to your interest? Is it getting higher or lower? Higher. The more you compound, the more interest you are. Okay, so I'm actually going to skip the next example. I'm going to go to this one. So I want to find what investing $10,000 at an annual rate of 10%, compounded continuously, for 2.5 years would yield. When you see the word continuously, what does that mean?
It's constant.
It's constant, so that means we are using the second formula. So anytime you see continuously, it's this formula. So A, do we know our ending amount? No. P, what do we have right now? 1,000. R, what interest rate do we have? 0.10. Right, this 10%. Time is 2.5 years. 1,000 e to the 0.1 times 2.5 power. So the e, you do the second natural log button. So we get 1,284. Zero. I would like for you guys to try a problem. So see if you can figure out this next one. Want the present value. So 100 is the future value. That's our A.
Yeah, that's what I was
So you guys flipped them. You treated the 100 as what you had now.
I saw present value, I'm like, oh,
Yeah, find the present value. So we don't know P. Interest rate is 6%, compounded monthly, so that would be 12 times a year, and we are doing 2 years. So it's regular compounding. So 100 is what we need to end with. 0.06 over 12. 12 times 2 power. So you can simplify this, or you can just divide it all over at once. You can do that. We get the 8870. Your present, or sorry, 8872. Your present value will always be smaller than your future value. Okay, as time goes on, interest will accumulate and your number will grow. All right, I want to try a couple more where we're solving for different things, and then we'll probably be done. So what annual rate of interest? So we are looking for the interest rate. Compounded semi-annually. So N is every 6 months, so it'd be 2. Should you seek, if you want to double your investment in 5 years, so our time is 5. Did I tell you how much you have right now? No, I just told you you want to double it. So there's different ways of doing it. You can use variables. So P is what you have right now. If you want to double that, you would end with, if you have P and you double it, you end with 2P. People usually prefer just to plug in a number. So if I didn't tell you, you could say, okay, let's say I have $100 right now. How much would I end with if I double it then? 200. So my amount right now is 200. Or my amount is 200. I have 100 right now. 1 plus, I don't know R. N is 2. Do the 2 times 5 power. Divide by the 100. 5 is 10. How would we get rid of a 10th power? 10 through. Then what would you do? Mm-hmm. And so the final step would be to take it all times 2. So, now 2.
So I have a question, I didn't
Yeah.
really get like how you got the 200 for the
I just
education.
made up numbers because it said it was going to double.
Okay.
So
Oh, okay.
you could have picked any number you want to start with, and then you just double it to get your income
So
out.
you could literally
So-
just put like 2 and 4 or something like
Yep.
that? Okay.
So like 1, 2.
Mm-hmm. And if you had left it as, 2p and p, you would divide the p over, and you get to the same point every time.
Okay.
Alright, let's look at this one. What rate of interest compounded daily is required to triple an investment in 3 years? So do we know how much we have right now? No, so give me a number. How much do you want to pretend we have? $3. And if you want to triple it, you would have 9. Okay, we are looking for the interest rate. Number of times a year would be 365. Our time is 3 years. So we divide our 3. Okay, 365 times 3. Okay, so how do we get that over?
1090 bit through.
So then we can subtract our 1. And multiply by the 365. It's a beautiful one, isn't it? So you would need like a 36.64% interest rate. Do we need more practice, or do you guys feel like you know what you're doing on these?
I think I'm good.
So there is a handout on Google Classroom with some interest